3D scanning is nothing new, but it's becoming more and more accessible. We're here with Francois from PL3D to talk more about how we can use 3D scans for our automotive projects. So 3D scanning is a term that we're hearing more and more often now. I feel like a lot of people don't really understand exactly what it means. They get their general gist that we're taking photos of something, scanning the 3D structure, but can you explain to us maybe just the basics of how 3D scanning works and if there's different types of 3D scanners?
Okay, so basically a 3D scanner is a device that will convert an existing object and bring it into the digital world. So it is basically, in our case, our 3D scanners use what we call structured light, what's called structured light. So the principle is they will project a light pattern onto an object, and this light pattern will be observed and interpreted into 3D data through a set of cameras that are mounted onto the device.
So, and then the computer basically creates a 3D model from that.
Yes, exactly. So it's done in real time. So it's going to create a mesh file, so basically triangulated surface, and display it in real time. So you basically go in as you would with a paint gun, but instead of painting, you're actually 3D scanning your object.
So yeah, you're trying to cover the object from all different angles to collect the data, work around it.
Yes, exactly, because that's kind of what's tricky with creating a 3D model is you need to observe it from every possible angle. So you need to know, how it looks from this side and from this side and from this side. And so that's the reason you're using your scanning and you're hovering around, over and under your object as you're doing with these devices.
Right, so for us working in performance, automotive or motorsport applications, how can this be useful for us?
Oh, this is actually extremely useful because, as you can imagine, when starting from a car, you can't exactly go to Jeep or to Dodge and ask them to send them their CAD files for your car. So you basically need to figure it by yourself. And so what a lot of people are doing is, they're taking these cardboards, they're cutting it to shapes, they're trying to do some measurements and trying to figure, where the mounting holes are, what the dimensions are, and basically how they're going to fit their components into their car. So the components that they're building. And so using a 3D scan is going to give them a digital clone of the object or the car in this case, and it's going to let them design components and have them fit it directly into the car and make sure that, the bolt patterns line up and that everything fits as expected the first time.
Right, so yeah, that's one of the key uses for it, I guess, is using it rather than measurement data in CAD to design new products or just new components to fit with existing things. Can it also be used for reverse engineering if we have something and we have the physical model or part and we want to bring that into CAD rather than modeling it? Can we use a 3D scanner then?
Oh yes, absolutely. You can use a 3D model for doing that. And usually a certain component is going to be part of a more complex assembly. So if you want to do interface analysis, interference analysis, and or if you want to build components that are going to fit into that assembly, that's definitely a good way to go, yeah.
So the actual process of bringing the scan into CAD, what type of file does a 3D scanner make and how do we work with that?
Okay, so our 3D scanners will generate what's called an STL file. So it's a file format that's been originally designed for 3D printing purposes, but that's also compatible with CNC machines, for instance. So it's basically a reference, a very accurate reference. But then what's interesting with our solutions is if you want to take it further, if you want to bring it into your CAD software, an STL file is usually not ideal. So we have a piece of software that will let you extract the different measurements, the different entities, surfaces, cross sections, everything you need basically to perform reverse engineering and basically go back to the design intent of the part that you scan.
So the key point there is STL file is a mesh, right? Which is like a surface kind of built up of lots of little elements and vertices. And that's not exactly what we use in CAD for our designs, and we can then use from CAD to manufacture.
Yeah, exactly. An STL surface is basically an arrangement. It's a single layer surface, but made of disorganized triangles, basically. So it was invented for the purpose of expressing a surface and send it to a 3D printer. But it's not ideal for CAD. So CAD software usually work with more mathematical surfaces. And so, yeah, that's the reason why it's really interesting to have that middle piece software inserted into the process and really extract information that's useful for your design, and basically integrate it and use it into your CAD software as a start point for your design.
Yeah, that's good to hear, because one of the key issues with working with meshes in something like Fusion 360, for example, is you need to bring that mesh in, tidy it up, do whatever, and then convert it to a solid body. But you lose a lot of, I guess, the design intent if you're reverse engineering something.
Yeah, exactly. So, it is possible to extract these entities, these measurements, these surfaces. We can also import your STL file. So it's hard to interact with an STL file within a CAD software, but it's always interesting to have it as a visual reference and basically sketch over it, build over it, design over it, and see how your design actually compares to the existing scan part.
Yeah, so using it as a reference. Just moving on from here, so your product, can you just explain roughly the price point of it and what it's capable of?
Yeah, so this product that we have on display here is called the Peel 3. It came out about a month ago. So it's a product that starts at $8,500. The scanner and software itself. So software is permanent license, so it is going to work basically forever. And then you have this additional piece of software if you want to work with your CAD software. There's this bridge to CAD software module. This goes for an extra $3,500, so it's a $12,000 solution in total.
So that's not a crazy amount of money, I know, when we're talking about 3D scanners, but it's still significant and maybe out of reach of a lot of home enthusiasts, but maybe not out of reach of people with small businesses who are going to be getting a lot of use out of it. I wonder though, I know the iPhone, you know, or most of the phones in our pockets now are getting capable of 3D scanning. What is the key difference here? Like, what are you paying for with that extra money? What's the main difference between the scan that you'll get out of an iPhone compared to your product, for example?
Well, what's actually interesting with an iPhone is the principle it uses for functioning is actually quite similar to our scanner. So it's a projection of a light pattern. You can't see it because it's infrared, that's the reason, but it's a dot matrix that's projected and observed with a camera. The only difference is, you know, the baseline is really small on an iPhone, so the accuracy is not going to be very good. And of course, you know, when looking at a product like a Peel 3D or even a Creaform scanner, optics components are going to be a lot better. It's something that's actually designed to scan objects, so not faces. So an iPhone is an interesting thing to play with, to start with, you know, to scan your dog or your pillows around the house. This is more of an industrial tool, so it's something that's going to be used to scan motor parts, car parts, or any existing object in a professional grade application, basically.
So yeah, resolution and accuracy really. So the model you're going to be able to create something that's really accurate. And was actually going to be able to fit in the end. I know the iPhones, they're great for basic things. You can use them in automotive applications to get a basic scan done, but not what you're wanting to work with for something really accurate, especially if you're going to be spending a bit of money on it.
Yeah, no, exactly. There's that, and there's also the quality of software behind. So if you're using an iPhone, you kind of left with, you know, whatever comes out of it. When looking at a solution like a Peel product or even a Creaform product, you get a software that's also built to be as efficient as possible and you know, guide you through the process of creating your object, using your 3D scan as efficiently as possible, and keeping all the accuracy and guiding the user towards its final objective. So that's really the...
Yeah, and with the texture or the color that we get from it, if you scan something, are you going to be able to see that? And what use would that be?
Yeah, so there's a couple of interesting applications for color. In industrial applications, we could think of annotations, for instance, design lines, styling lines that you'd want digitized and brought into your software for reference, per se. But the color part of 3D scanning is more, I think, interesting for applications like creating digital content for things like the metaverse, for instance. There's a lot of interest into that. Museums, educational applications. These are all domains or fields of applications that are going to be interested by the color.
Yeah, so not necessarily useful to us if we're just creating models from this, using it as a reference or reverse engineering, but interesting nonetheless.
Yeah, exactly. So it's kind of something it's a nice to have. What's also interesting is the color can be used to further improve the tracking capability of the scanner. So it uses the geometry of the objects, it can use the texture of objects, and it can also use these little markers, these little dots that we placed onto the object to help it further position and keep its accuracy.
Yeah, so I wanted to touch on that next, really, the process of actually scanning it. We often see these dots all over it, and some people would say that that's something that you must have to scan, or would assume that. What's the case there? What are these used for?
Okay, so the dots are actually the best way to achieve, or to make sure that the scanner achieves its accuracy. So it's spec accuracy. So if you look at a scanner like the Handy Scan, our higher end product, it is going to require targets in order to make sure that it has its accuracy all over the scan. But if you look at other, newer scanners, these can actually rely on the geometry of the object for positioning. The only unfortunate thing with this is they rely on the object for positioning. So if you have a lot of nooks and crannies and details on your object, it is going to work perfectly fine. It is going to figure itself and be able to let you scan. The thing is when you come to, let's say, a good example is a body panel for a car. You see it's a very flat area, so it's hard to grab onto it, and it's hard for the scanner to position correctly. And that's where these little dots come in handy. They basically act as nails between the different images caught by the scanner, and they will ensure that everything is at its right place and that the scanner doesn't make a mistake when scanning the object.
Yeah, I guess if you think of it as like the frame size of it, if it's moving across the surface and everything looks exactly the same, it's hard for it to track where it is as it moves.
Yeah, exactly. I mean, it's as if you were stacking sheets of paper on top of each other. They will tend to slide on each other. So you're basically stapling them together with targets. That's what you're doing.
And just on top of that as well, dimensional accuracy. When you take a scan of something, you need to take some measurements, so when it's in CAD or whatever software you're using to scale it.
You can if you want to. Basically, a scan is a ton of measurements, basically. So it's everything is a measurement. So any dimension on your scan will have basically the same dimension down to the accuracy formula. Yeah, so even a scanner like the PL3 will be accurate down to a few thousand. So it's pretty dead on accurate. But yeah, so you can extract specific measurement if you want to. You can measure things like cylinder diameters, distance from point to point, things like that. But you can actually use the scan itself as the measurement and rely on it for creating your scan too. You can do that.
That's really interesting. So one more thing I wanted to touch on, shiny surfaces. We see on the car behind us as well. Does it have any problem with the reflections?
Well, it's actually something that we've been heavily working on over the past few years. So it used to be something very difficult to deal with. Things like car paint, chrome parts. The newest generation of scanners that we have are doing amazing with that. I've seen it. For instance, the car that we have, it scans flawlessly. Dark plastic parts, it's superb. I've seen it scan chrome parts, and to my own surprise, it was working perfectly well. The only thing it still struggles with are translucent material, and the reason for that is, of course, we're projecting light onto the object, and it gets absorbed. It goes through the object, basically, so it doesn't provide any reflection. And so what we do with that is we apply a thin coat of spray powder, and we're actually going to be scanning the coat of spray powder instead of the actual plastic part.
Okay, that makes sense. So it's really becoming more and more a powerful and useful tool, and more accessible, and that's only going to continue as time goes on, I guess.
Oh yeah, hopefully. I mean, I've been with Creaform for the past 15 years, and I've seen these things progress at an alarming rate. It's really impressive the way we've come, and I'm really happy with the product that we have. The Peel 3 is an amazing scanner. It's priced at a very interesting price point, and it's great for businesses that aren't sure about getting into 3D scanning, that want to try it into their business model, that want to make sure that it fits into their workflow, their processes. And the great thing with Peel 3s as well is, since we're connected with Creaform, is, you know, if at some point you want to upgrade to a higher end scanner, you can always let us know, and we'll give you a full credit in exchange for your scanner on the purchase of a Creaform scanner.
Sounds like a pretty good deal. Computers also developing really quickly. Is there any kind of issues that people starting out or need to have some basic kind of performance in their computer? Because obviously dealing with a 3D scan file, it's a big file. Will most kind of modern computers be able to deal with that?
Yeah, well, I mean, the scanners are designed to be using standard computers, standard off-the-shelf computers. So there's a couple of things that you need to look for. You need a decent GPU with 6 gigs or more of memory. You need a good CPU, so an Intel i7, and a good amount of RAM. But other than that, it's pretty standard stuff. So it's something you can get at your electronics store, Corner Street.
Yeah, maybe just not the old computer that you pulled out of your wardrobe from 10 years ago or something.
No, exactly. It's better to go with a recent computer, kind of high-end spec, but standard. Nothing fancy there.
Well, that's great to hear. If anyone wants to learn more about your product, where can they go?
Yeah, so just go to our website. So it's peel-3d.com. Yeah, everything is there. You can also check our YouTube channel. There's a lot of information there as well. So it's a Peel 3D channel. And also look us up on Instagram. We're very active. So Peel_3D on Instagram.
Great. Well, thank you for your time. Cheers.
Thank you. Thank you very much.
If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.